All right, let's talk about a phrase you see everywhere. In the news, in scientific reports, you name it. It sounds super official, super important, but honestly, it's probably one of the most misunderstood ideas out there.
Yeah, this one. I bet you've seen this a million times. A new study comes out, and they drop this line like it's the final word. It's treated like the mic drop moment of data, the ultimate proof that they're right. Case closed, right?
Well, what in the world are they actually telling us? What is this p-value thing? And what's so magical about the number 0.05? That, my friends, is exactly what we're going to figure out right now.
To get our heads around this, we're not going to wade through some super complicated medical paper. Nope, we're going to use something we can all get in a heartbeat, a good old-fashioned coin flip. It's the perfect way to build this idea from the ground up.
Okay, so forget the lab coats and the complicated spreadsheets for a second. Let's just run a little thought experiment together.
Picture this. You take a totally normal coin, and you flip it 10 times, and you just write down what you get each time. Simple enough? And when you're done, you look down at your notes and... That's weird. Out of 10 flips, you didn't get something like 5 heads and 5 tails. You got 9 heads.
So what's your gut telling you? Is that just a wild random fluke? Or is there a little voice in your head going, I wonder if this coin is rigged? That question, that exact moment of suspicion, is the whole point of statistical testing.
Now, in the world of science and stats, you can't just jump to the exciting conclusion. You have to start from the most boring, plain vanilla assumption you can think of.
And this boring default idea has a fancy name, the null hypothesis. You can just think of it as the nothing interesting is happening hypothesis. For our coin test, the null hypothesis is simply the coin is 100% fair and any result is just random luck. It's the baseline we have to argue against with our data.
Okay, so we have our weird results, 9 heads, and our boring default assumption, the coin is fair. So, how do we decide if our result is weird enough to doubt that default assumption? We need some way to measure our surprise.
And that's where the p-value comes in. This is the absolute heart of it. A p-value answers one very, very specific question. If the coin is totally fair, what are the chances of seeing something as crazy as 9 heads or even crazier just from pure dumb luck? Now, listen closely because this is crucial. The p-value doesn't tell you the chance the coin is fair. It tells you the chance of seeing your data, assuming the coin was fair to start with.
So a really, really small p-value is basically a measure of how shocking your result is. A tiny p-value for getting 9 heads is like the data screaming, "Whoa, this would be incredibly unlikely to happen by chance if this was just a normal coin." It's a huge red flag that makes us suspicious of our boring, the coin is fair idea.
And that brings us to that famous number, 0.05, or 5%. For decades, this has been the traditional line in the sand. But it's really important to note, it's kind of arbitrary. It's not a law of nature. It's more like a gentleman's agreement among scientists that says, you know what, if there's less than a 5% chance this result happened by luck, it's surprising enough for us to call it statistically significant.
So let's pull all this together, because this right here is the most critical part, where we fix the #1 misunderstanding about what significant actually means.
Here's the trap we all fall into. We see that low p-value and our brain wants to shout, yes, my theory is proven true. But that's not what the math is saying. All it's really telling you is, wow, the data I just saw would be super rare if my boring, nothing is happening assumption were correct. It's poking a hole in the default theory. It's not proving your new one. So the next time you see that phrase, just think of it like this. A low p-value is not a certificate of truth. It's more like a reading on a surprisometer. It tells you your result is weird if you assume nothing special is going on. It absolutely does not prove your alternative theory is correct. I mean, maybe our coin was biased, or maybe we just got ridiculously, insanely lucky. The p-value alone can't tell you which it is.
Which leaves us with a pretty big question. If statistical significance isn't the slam dunk proof we think it is, then what is it? Well, it's a clue. It's a signpost. It's evidence that says, hey, you should probably investigate this a little more. So when you see that headline, you'll know it's not the end of the story. It's really just the beginning. It's an invitation to ask the real question, what's actually going on here?